Was it positive? Did it come out of the calculator positive? Yes. And to the left, this guy left is negative for x. Is this guy negative? Did it come out of the calculator negative? Yeah. Double check that, because if you screw up the trig angle, you tend to get the minus signs wrong. You don't get the minus sign, or you get the you switch these guys, like this one's this one, that, right? You'll get the same two numbers, but they'll be all mixed up, unless you do something silly like do subtraction wrong. Okay? So when you're doing your homework, make sure as you look at the vector sheet, don't get an answer that's got like the wrong minus signs on there and go, oh, that's good enough. Or at least if you do that, please don't design the car that I drive. Because it's not good enough. You've got to get the minus signs right the first time. You've got to be that good. Okay, that's the expectation, is that you can get those numbers right the first time. You're not just going, oh, well, I'll just make that positive. No, no, no. You got it wrong. Figure out why you got it wrong. Okay? Yeah? Okay, so let's have you guys try this one. Not that one. Try that one. See if you can do that one. Yeah.
Do you always use cosine and sine?
Yes. And cosine is always the x, and sine is always the y. If you have the trig angle. If you don't have the trig angle, then it'll take a little figuring. You can do it without using trig angles. But your calculator does that, and every calculator with sine and cosine does that. While you are working on that, if you would pass the little circular protractors, if you would pass those toward Mount Hood, the circle machines. Once the circular protractors have gone by you, then pass, they are circular protractors, or circle machines. Once they've gone by you, if you could pass the little rulers toward Mount Hood.
You have to do cosine first. Straight line machine.
Cosine will give you x and sine will give you y, and it doesn't matter which way.
Cosine's always x, sine's y.
Yeah. You always put the x component first, then the y component. Yeah. Next thing we want are the little maps, the little sets of directions. Yeah.
Okay.
It doesn't matter. As long as you understand that that's the y. Yeah.
Yoki thinks smart, that's why.
Say it again.
That is the answer.
Yeah, see how I drew them here? This is drawing the components. Yeah, you do. Look like that, right? So, you guys are all working on this, right? I expect the y component to be up, the x component to be to the left or negative. I just expect that. I expect the y component to be larger than the x component, bigger in magnitude. Yeah, it should come out negative. So just go ahead and follow your trig, find your steps, right? Find your trig angle, and then just let the calculator.
Do you want the user to keep them?
Yeah, and then once everything's on the end there, you could then pass down your graph paper with your little things. Make sure you put your name on it, I'll give you some points. Your x? What's your trig angle? What's your trig angle?
Experiment number 5.
It's more than 90. Less than 180. Here's 90. Here's 180. It's in here, right? So it's between 90 and 180. No.
Of course not. Of course not.
Yeah, so now write it like that. Like this. Write it the way they do in college. Magnitude, in this case, is 23. The length of the vector. Yeah. That's an always. Thank you, sir. Thank you for organizing those.
Cosine of the trig angle?
Yeah, it gives you the x component.
I got them all lined up. Don't unorganize them.
That's crazy. Look at these. These are like
Let me do
the devil.
What do we do for the last 10 minutes?
We're going to keep doing this. I'm just picking this stuff up. Here's some more.
Yeah.
Where's your, did I pick up the rulers?
Yeah.
Okay.
These kids are distracting me.
Those kids are?
Yeah.
I'm sorry.
I was like, you walking around.
Here's the answer.
Hey, Maria, what do you want us to do with our lateral acceleration? Now, am I supposed to put my name on like this? With a Sharpie.
So, can I go home and bring this to you back on like Monday or Tuesday?
Yeah, let's, boys and girls, could I have your attention, please? In my mind, we're learning one of the most fundamentally important parts of vectors, okay, which is finding the components of vectors. So we're not done. We've got 10 more minutes. We're going to do at least 2 more whiteboard problems, okay? You're going to write the answers on your whiteboards. Kudos to you if you figured out that this guy was 11.85 to the left, 19.71 up, okay? Pat yourself on the back, especially if you looked at this thing and you said, look, this thing goes up and this thing goes up. This thing goes to the left and negative means to the left. This one is longer than this one. This one's longer than that one, yeah? If you did all that, then I'm very, very happy. And then the final icing on the cake is that you wrote them like this. You did something, units, x direction. The meters per second come from that meters per second there, right? Okay. And then you did something meters per second in the y direction. If you did that, you're ready for college. Okay? You're just like, there's nothing more I can teach you, but let's try some of these guys. That one's too easy for you, is it? No, it's not. Let's do that one. We'll do that one and one more.
Very confusing.
Okay? I'll come grab them. What is the trig angle here?
Yeah, what's that?
Is it just 32.2? Yeah, it is.
Oh, it is?
I had some kids get that wrong in the last class, and it was like,
Don't mess them up. Are they perfect? Yes, they're perfect together. You only see them anyway because they're dirty, but...
well, that's awesome. And then if you like rotate it. Oops.
No!
You want to know something funny?
What?
I've done that before too.